database column, table columns. We talked about the unique attributes and that they becoming primary key in our SQL tables. We talked also about primary keys and also foreign keys. So can someone let me know what does foreign key mean and how we can specify the foreign key in a relation? Yes?
Is a key referring to a different table?
Yes. So it's actually a primary key in another table, yeah. So for example, consider if we have a two table, let's say department table and employee table. And in the department table, we have department ID as the unique identifier or the primary key. If this department ID, which is the primary key in department table, appears in any other table, then it will become foreign key. And that is actually how we connect that table to other tables. For example, if the employee table is connected to the department table, what column actually is connecting these two tables? So we have, let's say, we have employee table here, and we have employee ID, name, and some other attributes. And let's say name is the, employee ID is the primary key here. And address and department ID. And then we have a department table with department ID, department name, and some other information. Here, department ID is the unique identifier, and so it is the primary key. Here, employee ID is the unique identifier, and so it is the primary key. So the primary key is actually the unique identifier for a table, which means that we cannot have two equal values of that column in two rows. So there is no repeating employee ID. We don't have two employees with the same ID. Or for example, imagine a student table. A student number can become the primary key because we cannot have two students with the same number. The reason sometimes we don't use the name or other fields, for example, as the primary key, even if, like, let's say in a table, in a student table, we don't have two students with the same name, I still suggest using a student number as a unique identifier, because later you may want to add a new student with the same name with the existing students. So is the primary key clear? Okay, so now the primary key in one column, when it appears in another table, it becomes a foreign key in the second table. So department ID, which is a primary key in the department table, will become a foreign key here. So does foreign key, should foreign key be unique in a table, or can it be repeated? So can department ID be repeated here? Yes. Why?
Because you can have multiple employees in one department.
Yeah, exactly. So we can have many employees in the same department, and also department ID is the foreign key. So foreign key can be repeated. Can we have same department IDs in the department table? No, because it's a primary key. So we cannot have, let's say, if it's the business department or computer science department, and this has, let's say, ID 1, this has ID 2, we cannot have two departments with the same ID. For example, we cannot have the social, let's say, psychology department with the ID 1. This is not correct, because this is the primary key. And what I was telling about the foreign key was actually foreign key helping us to link the tables together. So later, if you want to writing a query to, let's select some employees and seeing which department an employee is working on, this actually helps us. So in order to understand, if we don't have this column, how can we know which department each employee is working, right? So we need this column to actually connect these two tables together. Now we know that, for example, employee Alex with some ID, let's say 1AB Alex is working, let's say, in department computer science, right? We don't need to explicitly write the department name or other information in the employee table anymore, because we already have the foreign key, and foreign key actually connect these two tables together. So knowing that Alex is working in department ID 2, we can actually retrieve all other information also here. So this is the concept of foreign key and why we need it. And so today we want to work a little bit with SQL. And so SQL is actually stands for a structured query language. Is one of the many query languages for accessing or manipulating the databases. And so it's developed by the IBM, and it can be used by many relational database management systems, such as, for example, IBM DB2, MySQL, Oracle, SQL Server. So these are the names of the softwares or the RDBMS that we use. But the SQL itself is the language, is the query language that we are using. So this is an example of the SQL create table statement. So we are going to practice creating tables and let's say inserting information into tables and some other basic queries today. But this is for now just to have some ideas how to create a table. So you start with create table, table name. So create table is always fixed when you want to create a table. And then you put the table name, for example, create table student. And column 1, let's say, can be student ID. And then the data type, which represent that what is the type of the data in that column. For example, we say that if, let's say, a student number is only numbers and doesn't contain any letters, then we can define it as integer, for example. And depending on how much is the length of that data in that column, we can define different types of integer, which we also talk about different data types today. So let's say, for example, create table student. Column 1 can be a student ID with the type, for example, int or numeric. Column 2, what can I write here?
Student name.
A student name, data type. What do you think? Characters. So there are actually here two different types to define the characters. We can use either char or varchar. Varchar, the difference of char and varchar is actually char is fixed, but varchar is variable. So if you know, for example, all a student, for example, let's say names are going to be, for example, I don't know, 6 letters, and that's fixed, then you can use char. But in case of name, actually, everyone can have different names. We don't know the length of the name of each person. So we use varchar, which stands for variable. And yeah, you can practice actually in the W3 schools, which is a cool website if you have no experience with SQL. I remember I myself started learning SQL with W3 school many years ago. It's simple but very useful, especially if you're a beginner. So there are different types of SQL command. We have data definition language, which mostly we will focus on the data definition language or DDL today. We have data manipulation language, data control language, and transaction control language. So what is the DDL, or what is the Data Definition Language? It's actually, we use DDL to create and modify the structure of our database. And as you can see, it's a set of commands to create and modify the structure of the database objects. And by database object, I mean, for example, tables, views, schemas, indexes, etc. And the objective of the data definition language is to actually letting us implement the database. Do you remember the third step in designing the database? We talked about converting our ER model to relational schema. Now that relational schema, for example, if you remember, I also mentioned that these relational schemas, for example, let's say if we have relational schema for employee, will become the tables, SQL tables, right? So this is actually, we use the data definition language to be able to actually, how to say, enable the implementation of these relational schemas into actual database tables. So there are different commands here that we learn today. For example, we will work with create, like for example, create tables or databases, alter, which is for modifying the information in a table, and drop when you want to, for example, delete a table. So this is an example of the database schema. This is actually a relation or table schema because it is only about one table. So when you want to design your database, before going to writing queries to create tables, it is always suggested to create your schema first, which gives you some structure and plan to know what to do. For example, in a table schema, we say that what are the table names. For example, here we have 4 tables: products, orders, order line, and customers. This is similar to what you have done for your assignment 1. So assignment 1 was about like ordering from a flower store, and in that example, some of the main entities or tables were product, customers, orders, and order line, right? Now, before implementing the database, we create the schema, and we define, for example, what attributes or columns or fields we have in each table. For example, this is not a complete schema. For example, you may have more columns for the customers or products, but this is just an example. For example, let's say for the product, you have the product ID or code, you have description, name, price, etc. You have to define the key data types, whether you want to allow nulls or not. This is very important for the for ensuring the referential integrity, which we will talk about later today, and also foreign keys. So, for example, in the product table, what was your primary keys and foreign keys? Can someone help me? So what was the primary key? It's actually here in the product table. Yes?
Code.
Yeah, and what was the foreign keys? So let's say if we have product code, description, and price only here. So do we have any foreign key? No, because there is no primary key. For the orders, again, order number was a primary key. Here we have a foreign key because customer ID is actually the primary key in another table. So why order number in the order line is foreign key? Yeah.
Because it references the order number.
Yeah, exactly. exactly, because it refers the order number in the orders table, and because order number here is primary key. So whenever it appears in other tables, it will become foreign key. So you are basically in a schema, you define your tables, what are the columns of each tables, what are the primary keys, what are the foreign keys, and the data type of each column. For example, when you define that for the unit price, for example, you have numeric, you cannot use any character values there, because for the unit price, we expect numbers, right? So this is numeric. And so, or for example, if we have ordered date, we would expect the data type to be date. And so we cannot insert the date just numbers. It should be in the date format. And here, the numbers that you see inside, for example, when we have character or char 4, 4 means it has 4 letters, for example. This is the length of your data. And for the numeric, for example, when we have 8, 2, it means that the number can be up to 8 digits. And 2 shows the decimal, the number of decimal points, up to 2 decimal points then. So, can someone tell me what is the difference between a schema and a table?
Schema is the one that arrows and you can show the figures that comes like a map kind of. It has bolded terms, it's more simplified, and it usually doesn't have sample data. Versus the table, you can break it down and you separate each entity into its own table and you can sample data.
Yeah, so that was actually a relational schema, but that's correct. So this is like our plan, and it's a logical structure of our database and tables. It's not the actual table. While the table showing each table is representing a unique entity, we have rows and columns in tables with a lot of data in table. Not actually, we can have even a few data, but with information in table. So here you can see some of the SQL, main actually SQL data types. For example, numeric, which can be, for example, integer, float. There are also other types, but these are just the most common ones. We have character string, which we use for the string. Unicode character string, like nchar and npax. Basically, you want to know the most common ones are actually numeric, character, so int, float, char, varchar, and also date and time. So these are the most common types. So here I put a table for just the string data types. You can see all the different string data types here, their description, maximum size. So you can kind of compare what are the differences between each of these and when to use which one. Most of the time, char, varchar, and text are enough. And you can also see some information about like the, you can compare them in terms of the storage that they need. And this is an example of the SQL numeric data type. So you see, for example, we have bit, tiny int, small int, big int. So depending on the length of the actually that integer number that you want to like use in that column, you can use either small int or big int. So this description is for that, to know what, for example, small int allows whole number between these two numbers. So if your number is not going more than that, you don't actually need to use integer because it also uses less storage. If the space is an issue for you, if you care about like space, then it's always good to know what's the difference between these different types. And So you can also see here the float and real. So you see, for example, float is floating precision number data in a specific range. And real is also floating precision number data between some other ranges. So does someone know what's the difference between float and real? So float is actually, it's not very important, so you don't need it actually for this class, but in general, if you were wondering which one to use, float usually gives you an approximate numbers. So it's good for scientific cases, rather than, for example, for business cases or when you deal with financial applications or monetary applications, then it is not recommended to use float. So this is from your textbook with the most common SQL data types. As you can see, numeric xy, number with x digit, y of which are after the decimal point. For example, if you have numeric 6 and let's say 3 means it's 6 digits, and 3 of which are after the decimal points. So how we define tables in SQL. So as we saw in the previous slide, when we want to create a table, I write it here to stay, so when later you want to write queries by your own, you can watch the whiteboard. It's very easy. So when you want to create table, this part is always fixed. So create table, let's say table name here, table name, give me an example. I don't know, let's say product. And then you have the columns, data types, and here you also specify whether a column can be null or not. That is what you were seeing in your schema. So if you remember here, so the reason it's good to use this is when you want to actually implement your database and write your queries, it will become very easy. So when you want to create the table product, you can just check your schema. You know, for example, for the table product, you have these column names. So you write the column names. We have, for example, product code, description, and unit price. Code, description, and unit price. Right? And next to the name of the columns here, so these are our column names that you can see in the query. Sorry, give me a second. In this query. Here. So the first slide, if you remember, we had create table, table name, column names, and data type. And I also added that based on your schema, where you define, for example, which columns can be null or not null. For example, if a column is primary key, can a column that is primary key be null? For example, in a table of employee, can we have employee ID null? No. So that should be identified in your schema. So this was the main structure for the creating the table statement. And now based on our schema here, we want to substitute, for example, table name with our table name, which is, for example, the product table. And also be careful, if you define your table name with caps lock, it should be also caps lock here. But just be careful about the names. Let's say here we have products like this. Product code, description, price are the columns. And the data types. What is the data type of the product code? Product code is character here. This is because, okay, it depends. If product codes in your database are, for example, 1, 2, 3, 4, 8, 6, 5, 1, if these are just numbers, then you can define it integer. But sometimes product code can be like, I don't know, A, B, C, D, okay? So then, even including some numbers inside, okay? Still, this is a character. So, product code is defined character here. And there are two ways to define the primary key when you want to create the table. So either you can write the primary key name here or defining it at the end. So for now, what is the data type for the product description? Yes. So we have also, I myself were sometimes confused between text and varchar, but it depends on really like the length. Like text is more convenient if you have, for example, if you're storing data from social media and you want to like have texts that are very long, then you can use text, but in many cases, varchar is enough. And then unit price is numeric 82. And then you can either define your primary key here, writing what is the primary key, or even put it here. You can also write it here. And you can do the same with all other tables. We will practice more with your SQL databases on the VLab today. So these are just an introduction and just a few examples to get you familiar with the queries. So create table, for example, products, the column names, data types, and you don't need to define the columns that can be null. For example, product description can be null in a table, right? Some products may like have no description. It doesn't cause any problem in our table. But product code, because it is a primary key, it should be not null. So always primary keys should not be null. And then you define your primary key either here, and don't forget to put the column that is a primary key in the parentheses, or just next to it. And then create table, for example, customers, the same way. Now here you can also see how we define a table which has also a foreign key. For example, when you define the table, column names and everything, so the same way that you define the primary key, you also write foreign key. Okay, foreign key, parenthesis, column name. Here in the order table, customer ID is foreign key. Why? Because customer ID is the primary key in the customer table, right? So this is a foreign key here. And the syntax is foreign key, column name, references, because we have to know which table this column or this foreign key is linking to or referencing to. So customer ID reference to which table? Customers. So customers, their customer ID is the primary key. So this is actually the information of this. Okay, this is the order table. Order table. Let's say we have order ID or number and customer ID here. This is the primary key and this is the foreign key because here. Sorry, I have to move this. So here we have the order table and customer table, customer ID, which is the primary key here. Okay, so now when we want to define the table, so in order for your server, for your computer to understand your query, so you create a table. This is just an empty table until you define the columns and order number, customer ID, order date, and the foreign key, which is the customer ID. So when we use references here, that references is actually this link between the foreign key in this table with the primary key in the customer. This is to understand or knowing that the order table refers through the customer ID, we are referring to the customer table. So this is referencing the customer table using the customer ID, right? The customer ID is the common field between the two tables. So always when you have foreign key, in your table definition, you have to have this. And again, this is the reason that we need a schema, because that was all we defined in the schema, right? That's like our plan. And create table order line, the same. So we have, for example, order number, integer. So why order number and product code cannot be null here in the order line table? Yeah. Yeah, because they are actually our composite primary key. They are both primary keys here. They cannot be null. And here are the data types. Primary key, and look here, we have two primary keys because this is a composite primary key, and foreign key. So you also list the foreign keys here like this. So today, when, yes?
In the last slide, there was something about integer identity that said generate.
Oh yes, sorry, yeah. So that is when you want your, for example, numbers in a column starting from a specific number. Let's say, for example, if your numbers is starting from 1 million, and then 1 million, 1 million, 1, 2, 3, then you can identify that. That's why we have here. So integer identity means that it generates order numbers automatically starting from 10,000. So when you want to use your databases today, you may need to also specify which database depending on where you start writing your query. I will show it to you later when we are actually using the SQL. So if you, for example, right-click on the database project DB1, then you don't need to specify the database because it knows that which folder you're writing the query in. But if you go to like the parent levels, then you have to specify the name of the database. And SQL statement is not case sensitive. Another thing, like that one of the reasons why the SQL is very popular is because it can be used by many relational database management systems, and although like there are very small differences in the syntax, but generally when you learn SQL, you can use it. You can use, for example, MySQL. You can use SQLite, Oracle Server. So you can use any kind of relational database management system, and there might be like just very small differences, but the main concepts are the same. And so here are some notes when creating your tables. For example, SQL statement is not case sensitive. No space for table name and column name. So for example, if you have product ID as your column name, just be careful not having a space in the names. So you can connect them with, for example, underline. Pay attention to the format of used parentheses. Data type should be consistent for the same attribute in different tables, such as the foreign key and corresponding primary key. What does this mean? What does it mean that the database data types should be consistent? Yeah.
Like if you're having order ID and you're putting in numbers and strictly numbers, it should be integers and not anything else. Like you need to specify it so it matches what you're actually putting into the database.
Yeah, and if we define it like integer, so in all tables it should be integer. We cannot define, for example, department ID in the department table integer and then defining it in another table as, I don't know, character. So the data types should be consistent. So after we created our table, we need to insert some data. So the previous statement, when we have the create table here, table names, I leave it here for you. Table name. And here we have column names. Here we have data types. Whether they are null or not, you only need to specify if they should not be null. When it is like not specified, it means that they can be null. And primary key, which can be defined either here or here. So now, let's say if you have also a foreign key in a table, then you define it like this. So foreign key, the name of the column of the foreign key, and then use references. Can everyone see here? I'm not sure if you can see. So references, which table? So table name and column name. So this, actually that statement, create a table for us, let's say for example, order table, but with no data in it, because we just defined what is the name of the table. So in our database now we have a table, for example, order or product or whatever that we created. We created also the columns. We specified the data types and everything, but we still don't have any information in that. So we are going to learn how to manually insert data using the SQL query. So this is the syntax. Insert into the table name. You can either specify the column names or skip that, just directly putting the values. So insert into products table, product code, description, unit price. These are the column names. And then values, whatever values that you want to enter. Why some values here have comma and the others are not? So why can we have a 0 to 1? I mean, why we have used this?
Because those are strings and then integers don't need.
Yeah, exactly. So because we defined the data types for the product code and product description as characters and varchar, which are used for strings. And whenever we have data types for strings, I don't know whether they are text, character, mchar, varchar, different types of string that I put a table for your reference in your slides. Whenever we have a string, we have to use this. Otherwise, if it's integer or numeric types, you can directly put the numbers here. And so these are two different types of inserting information. Both are correct. Here, you just ignore the column names. And then, for example, insert into customers, these values. This is inserting multiple rows at once. You don't need to repeat insert into values several times if you want to insert, I don't know, 5 rows. You don't have to write 5 insert into. So it's only enough to write 1, and then you can just put in those values in parentheses. So these are going to be in your row 1. This will be row 2. This will be row 3. Two values until row n. And here you have your data. So whatever data that you want to insert into the tables are here. And these are your rows. So if you, in the first row of, let's say, order table, you want to have order ID, I don't know, A21. So you insert this. And then we have order description something again. And then, what was the last column? Unit price, for example, was, I don't know, some number, $100. And this is integer. So these are the data for the first row. In the table, what table was that? Product. In the product table, then this will be your first row. This will be your second row. And this will be your third row. So do you have any questions so far?
Does it have to be inserted in the same the same order as the order?
Yes. Yes. Yeah. So the order are also important, because if not, especially because we are not specifying, for example, the name of the columns. Let's say if you put like cordless here first, it's not. Also because the data types in different columns are different, then you are violating the referential integrity too. Because, for example, if you put 6.29 here, this is integer, that is character, so the order is important. So this is what we talked about using a string, such as, for example, your product code, which was defined as character. We use character or varchar depending on whether it is a fixed or variable character. Use number directly for integer and numeric using these date formats, and if you have like dates. So you may also use simplified insert statement, which is actually the insert statement without specifying the column names. The insert is subject to integrity control and constraint. For example, you should enter products and customers first, then orders, and then order line. So this is very important. We are going to talk about referential integrity later today, but for now, it's good to know that these integrity controls are mainly for the consistencies in our database. For example, what I mentioned about, for example, primary keys and foreign keys in different tables with having the same data types. Or, for example, cannot insert information in a dependent table before the table that is depending on. For example, if you want to insert information in the order table, you have to first enter product and customer. Why? Why we cannot insert information in the orders or order line first? I can go back to the schema to help you better realize. So what was saying was that we cannot insert into orders or order line before we insert into products and customers. Can someone tell me why? Yeah.
I'm not sure, but is it because of the primary and foreign key? So you would have to like have one to have the other? So you could
Exactly.
go backwards?
Let's say we want to insert information in the order table, and we still didn't insert any information in the product table, right? Now, if we want to insert information in the order table before we insert information in the customer table, what happens? So we have to insert the order number, which we may have. We want to insert customer ID and order date. So do we have customer ID? When we haven't inserted any information in the customer table, even if you think logically, it doesn't make sense to insert information in the order table before having any customer. So if you don't have customer, how can you have order? Who placed the order? Because customer placed order. And the same for order line. Order line also have two foreign keys. One is order number, which is connected to the order table. The other is product code, which is related to the product, connected to the product table. So we cannot enter information in the order line table before we enter information in which tables? Exactly, product and order. Why? Because if we have not inserted any information in the product table, we will not have product code yet. If we have not inserted any information in the order, we will not have the order number. So these are the meaning of referential integrity. Do you have any questions so far? No? Yep.
So is it basically you can't like insert data into like tables that don't have foreign keys?
Yeah.
First?
Yeah. Because foreign keys is actually linking the tables together. Okay. So the insert is subject to integrity control. Now we all know what does that mean. And now we learned how to create tables and insert information in the table. What if we want to alter those information? So we use the alter table command. So as you can see, here's the syntax. Alter table name. This shows the table that you want to alter some information. So alter table products, for example, we want to add product type. We didn't have product type before in the product table. This is a new column that we want to add. We use add, column name, and the data type. So always when you define a column, either whether if it is in the create statement or alter statement, if you are going to create a new column, you always have to define the data type. So even here, adding the column name, which is product type, then you have the data type, and adding foreign key. So if that column that you're actually adding is a primary key in another table, then you write add foreign key, writing the name of the column in the parentheses, references, category. So this is for altering the table. write it here. Alter table. Here we have table name. Yes, and then we add the column. Column name, data type. So for example, adding, I don't know, some column, what was the column name there? For example, product type, and defining the data type, whatever you want, like character, varchar. And if the column that you're going to add is the primary key in another table, it means that it will become the foreign key in this table. In that case, you write add, also foreign, I'm not sure if I'm writing the foreign right, add foreign key, always after primary key or foreign key. When you define the foreign key and primary key, write the column name in the parentheses. So here you have the column name, is the foreign key column name, and references. Here, the reference table. So in that case, the foreign key was product type, referencing category. Okay, we don't have space here, but when you reference the table, you also specify the column, which is here. So in the category table, we have product type. Another example, alter table products. Now we want to altering a column in a table. So alter table and then alter column, product description, varchar 880. So previously we defined the data type of product description. I'm not sure what we defined it. So product description was varchar 40, right? Now, if we want to alter this into 80, if we have more characters, now we have to use alter table products, alter column product description, and then you write the new data type. So you see the new data type here. Sorry, I know that this is very boring to listen to these SQL queries on the whiteboard, but I promise we will work on this like in practice today. I want you to get familiar with the syntaxes and the basic commands, writing them on the whiteboard for you to just stay in your mind, and then we will practice after break. And what if we want to delete or drop a table from the database? So here is the code, drop table, table name, easy. Yeah, again, you have to be careful about the integrity control. You cannot drop some tables before some other tables for the same reason that we saw for the insert. So for example, you cannot drop the order before dropping the order line. Why? Why we cannot dropping the order table before the order line? Back to our schema. So it says, yeah.
Because would it make like the order number null, but it can't be null?
Yeah, exactly. So you, yeah, like in worst case, even if you do, you get some errors, and then you can search for the errors and fix it. So it's not a big deal in real world, but like for your exam or assignment, it's important to know these. Okay, so do you want to have a short break? Because I feel like some of you are sleepy. So just freshen up and continue, let's say, at 1. Yep.
Any coffees?
Okay. Okay, so let's start with connecting to the SQL Server. So first, there are 2 Excel files in the Avenue to Learn. I would like to ask you to go to the Avenue and under the content for week 5, you will see the SQL databases for section 3. And then open that file. Knowing your student ID, you will know which project DB is assigned to you. So I assigned 1 database for each student. So I make sure everything will set up for you to practice at home. For now, so this is what should happen after you try to connect to SQL. I know for some of you it just stuck there or you received some error, but you basically just have to click connect, and then here is what you see. Okay, so are you creating the table? The ones that have access to SQL. Okay, so create table, customers. Now, what are the columns for customer table?
Customer name, customer ID.
Yeah, so customer ID, and what is the data type? If it can be int if the IDs are only number, but here in this example, I'm not sure if the customer ID it is a character, because sometimes, for example, like the Mac ID, it's not number. The Mac ID is, for example, your family name followed by your first letter of your first name. So customer ID here is also character, let's say with the length of 5. And then we have customer name and customer password. So customer name and customer password. Customer name also can be varchar. Here it is 20. It really depends on like your case. So like names usually don't go further than 20. And customer password also, like let's say password up to 10. We just have to change the primary code. Here is the customer ID. Another way, as I've told you before, another way of defining the primary key is just writing the primary key next to the column. For example, you could also write it here. So this is correct too. And also because this is primary key, it should not be null. So we also have to mention that this is not null. This cannot be NA. And primary key, we are done. So let's create this table. So we sorry. Yes. Yeah. Yep. So now it actually should execute. So now, after you created any table, just go to the databases and your project DB that you're working on. Sorry, yours was 135, right? So here we have the project DB, and under the tables, we can see the tables that we have created so far. So here, you can actually see that we have created the table customers and products. So now, if I go to this one, if I actually click here, under a table name, I can also see other information such as columns, keys, constraints, or if I just right-click, right? If I right-click and go to design, then I can also see the design of this table. Here, you can actually also manually edit this information if you want, like changing the column names and everything. So this shows the design of the table. And you can also, there are a lot of information you can actually check yourself. Like if I select top 1,000 rows, this shows me the top 1,000 rows of the table. So here we have no row or 0 row because we have not inserted any information into this table yet, right? So how many of you have created the table? You, and here none of you could connect, right? Oh no, it's you just have to refresh your So also sometimes when you create the tables, it doesn't appear here. Okay, so are you listening to me? So sometimes when you create tables, it doesn't automatically pops up here. You just have to right-click on your database and click refresh. Just go to this, right-click, click refresh, and then under the tables, you will be able to see the tables that you have created, right? Now, let's create also the orders and order line tables. So create table orders, and the columns are order number, customer ID. Okay, you can actually no. You can actually copy and paste the orders table from the slides. We just want to create the tables now and then insert some information. So yeah, you can just click them, copy and paste. Yeah, and then just click execute. Now let's insert some information. Okay, now that we have created the tables, we would like to actually insert some information into our tables, right? So now let's insert some information into, for example, the products table. So what was the syntax for that? Insert into, yeah, you can write. So insert into the table name, for example, insert into products, and then you can. Oh, it doesn't work. Thank you so much. So let's insert some information here. For example, as I mentioned before, when you insert information data into the table, you can also use the simplified version and just ignore the column names, or you can actually write the column names, like for example, product code. I just want to make sure I use the same names, product code, product description and unit price, product description and unit price. A21 and let's say some numbers. I don't know. Four. Instead of repeating the insert into, you can actually insert multiple values at the same time. So, for example, let's say, and then we have this.
So I can insert only one row for a time.
Yeah. You can either use like different insert into or just put them all together. Okay. So when you insert information into a table, so now, for example, we inserted some values here. Now you can also go to this table products. So you just go to the product table, please, and right-click the table, and then edit the top 1,000 rows. Select the top 1,000 rows. No, sorry. Just go to the table. Yes, select the top 1,000 rows. So here you can see the information that we just inserted. So today we could only cover how to create a table, how to insert. We also saw how to actually alter or drop a table, but we couldn't manage to do it by ourselves. I tried to contact the UTS today, and I will post an announcement. Just keep an eye on your Avenue to Learn. And I tried to make a video to cover the rest of the information and guide you to how to like alter and drop the tables. But if not, please just follow the guidelines in your slide. I've put plenty of screenshots there. Yeah, thank you so much.